Today's project is an easy one. The Tokamak nuclear fusion reactor. I mean, who doesn't know how to make a Tokamak nuclear fusion reactor? Everybody here is very familiar with nuclear fusion, right? You've all taken at least graduate level physics. So this is a project that I added to the 270 options kind of as a joke, and somebody decided to get snippy with me and pick it anyway. But, you know, it's their loss because they still have to implement it. You don't get out of it just because it's stupid. It's been a bear of a project for those people, for sure, but let's read the description so that we know what we're dealing with here. Oh, and the customer on this one is absolutely appalling, too. The customer thinks that this is incredibly easy to do and just demands that it be done. Anytime they ask about it, they just want to know why it's not done. The project is quite simple, and the budget will reflect it. All you need to do is generate a simple visual representation of the internal function and geometry of the Tokamak nuclear fusion reactor. Input particles should be simulated at the molecular level with support for zooming out to the macro level and ability to slow, speed, or pause the reaction. So just the fact that you have to simulate nuclear fusion pretty much takes this guy up into impossible land. But it's going to be a great one for us to look at some of the different limitations that mobile platforms experience when it comes to making 3D games and such in Unity. So at a certain point, we'll actually see that point happens. Relatively early on, my little $150 OnePlus Nord is going to go, it's not going to be able to do it anymore. So I'm going to switch this to an Android project. Got a little bit ahead of myself there, and while that's switching over, I'm going to open my 3D editor, if I can find where I put it. Okay. Good thing I have this person for scale. Yes, I know a new version's available. Mine is 3 years old. Good thing I have this person for scale so that I can decide how big to make my Tokamak. The groups asked me many times how big I wanted it, and I wasn't actually able to tell them because I don't know how big they are. I guess we'll find out. Okay, so first order of business is going to be to make the donut thing. So a Tokamak nuclear reactor is a big toros, a donut for all you peasants out there that don't know what a toros is. And it has magnets all around it, okay? And the magnets get a bunch of electrical charge, and inside of it is some special hydrogen, deuterium and tritium. I might not be saying those correctly, but deuterium and tritium, what, anyway. It's hydrogen with 2 nuclei and hydrogen with 3 nuclei. We'll look up the specifics later to make sure that I'm correct there. And when those two combine, they create special helium, and they release a ton of energy. To make them combine, you need to supply a ton of power to the magnets in order to get the kinetic energy of those guys really, really high, and then you end up with nuclear fusion occurring. You end up generating plasma inside of the reactor. And then nuclear fusion occurs, and everybody's happy. Okay, I need to change the lock surface here in order to create my donut. Oops. So I need a donut. I need to determine what width I want it. That looks good. Okay, and then I need to follow me. I donut. Genius. Alright. But there's a small line inside of this donut. It's never been my strong suit to get rid of the lines. Um, shoot. Do I just leave it there? Maybe one of you people with more art skills than me can tell me how I'm supposed to get rid of the line inside my donut. Here's my actual... Oh, okay, I can see it. There we go. Nuked it. And did that kill my... Nope, I still have my donut. Cool. I don't think Tokamaks have this big of a hole in the middle. But we'll roll with it. We'll roll with it. Okay. So that's how you build a donut. Now, for those of you who want to learn Blender, go try to build a donut and tell me when you're done in 3 weeks, because I just did it in 2 minutes in SketchUp. And this is gonna go to knockoff art donut. I'll just put it in the main folder. And it's only 576 faces, which makes it relatively mobile friendly. Like I said, anything under the thousands really is pretty mobile friendly. So we'll call this models. Waffles part of Battle Butters. Alright, let's get my donut in the scene so we can mess with it. Okay, first the big donut we don't need. We only need the mesh. So I want to unpack this prefab and just separate out the mesh, delete the empty game object containing the donut. This will be the donut model itself. Now it looks really small. Let's compare it to a 1x1 unit cube. The 1x1 unit cube absolutely dwarfs it. I want the other way around. I want the donut to be giant by comparison. So let's change the scale factor to 100. Yep, that's a big donut. Now let's see if the cube is... you know what? Let's go real serious mode. Let's get it very, very low, because I need it to be filled with particles, right? So I don't want to have to be messing with making the particles fractions of a unit small. Alright, now it truly dwarfs the square. Okay, lovely. Now it's made of the default material. I'm going to want this donut to be mostly transparent so that I can see the particles inside of it. So let me make a mostly transparent texture. Notice I usually make my textures 800 by 800. There's actually no special reason for that, just that I find that to be a good trade-off in terms of size and quality. If you have a texture with more detail, you should definitely make it bigger. Alright, 4 might be a little too light. Let's try, let's go 10 opacity. Yeah, sure. Transparent cyan. Okay. You know what? I'm going to rename this folder to imports. I'm going to make a folder called models in there, which is really just going to be donut. I don't think I'm going to make a model for the particles. I think I'll just use the standard sphere. And then we'll call this textures and mats. Actually, rather than imports, I'm just going to call it art. Textures and mats. Okay. There goes transparent cyan. Don't forget to check that alpha is transparency box if you're using a PNG with transparency. Now to create a material for it. As a heads up, I also don't have everybody's ideas in yet, so if you haven't yet submitted your idea, make sure you do so. The checkpoint is coming up very soon, too, so make sure that you're actually working on your application, you gotta have something to show me. Pretty soon here. Okay, so there we go. A relatively transparent donut. Nice. I could do like a cutout, which makes it even more transparent. But now it's like practically invisible. It'd be a little too transparent. If I add more color to it, no. Fade, cutout doesn't work. Fade, or a transparent. There are also other shaders besides the standard one. Sometimes when you want to deal with mobile, because the standard shaders are designed for PC and they're a little bit more expensive, you can try one of the mobile shaders. Vertex lit, not going to work for me here. Unlit, not going to work for me here. That's more for GUI and stuff. These diffuse ones can work for particles. The particle one is usually pretty good. Particle one. As you can see, it's not as pretty. It's definitely rendered on a budget. Yeah, let's try the particle one for now. We'll see how it goes. Alright, I want to position the camera so that you can see the whole donut. Donut centered, camera's not. I guess I need to move the camera up a little bit more to get a better axis on the donut here. And I might need to expand that field of view a bit too. It's a little bit small. That's a reasonable picture of it, but I think I want more of an overhead. And I'm looking in that game window to see what I want to see, right? I got a very small phone to work with here, so I got a very small field of view. This is looking decent. Maybe you don't want to see the whole thing. I don't know. Maybe this is good. Maybe you just want to. I guess there's no reason for you to see the sides of the entire chamber, huh? All right, this will work for now, for the Tokamak fusion reactor. Okay, so if I want the donut to have collision, which is definitely going to be the hardest part of this whole thing, I would have to give it a mesh collider. A mesh collider is based off of a full 3D mesh, so in this case it's based off of the donut. And mesh colliders are unbelievably computationally expensive. So in order for them to work at all, you have to check this is convex box, and then Unity will kind of do its best to build a actual collider for you. Okay, and as you see, although Unity has done its very best, the collider is not very donut-like at all. If I hide the mesh renderer for a second and you just look at the collider that it's created me, it's actually given me like a bowl. It missed the sides of the container completely, and there is no really recompute option. So your only real choice here, if the mesh collider is inaccurate, is to just go back to the drawing board completely, rebuild your model, or try to build your own collider, your own convex collider from scratch. You can do this in Blender, you can do this in SketchUp, but it's really, really hard to build your own colliders because you can only use convex shapes. The definition of convex is some complicated math juju that we're not going to get into, but yeah. It also tells me that the convex mesh that I tried to make was too big. I went over the maximum poly limit, so it will use a partial hull. This is probably why I'm missing some parts there. So I could go back to the drawing board and try to make my sketch simpler. The problem is it's just a bloody donut. What am I supposed to do to make this simpler? There's not much to be done, is there? I could make it smaller and see if that results in fewer faces. So let's say I made it smaller. Alright, so I could make it smaller. I could try to get rid of some of these extra meshes. I could maybe get rid of the inside. I don't know. Let's see. Let's see how big this one is. So my budget for making a proper convex mesh is, I think it's at 256 verts. Let's see how many verts this ends up as when I export it. 576 faces, which I think might have been smaller. Actually, no, I think that's the same size. I think that was the same size. So I wasn't able to save any vertexes. So I would either have to make a less detailed donut out of maybe cubes or something, or I'm back to the drawing board on the collision with this thing. And that's going to be the main problem in this project from here out, really, is that making the collider is going to be nigh on impossible. So I want to have collision with the sides of the donut. I want you to be able to hit the sides with the particles, hit the sides, and something happens, and that's going to simulate the magnet, because I don't have any real way to apply force at like an angle into the donut. That's going to be pretty much impossible. So I need the particles to be able to bounce off the sides of the donut. So what other options do I have for colliders? Well, there's a sphere, which gets me part of the way there, and then there's a circle. So I could use a sphere around the whole thing, yeah, and you can actually kind of squash the sphere, maybe? That could get me there. Right? But that's still not really a donut. I can use capsules. A capsule is basically two spheres and a rectangle. So let's play with the capsule for a bit. You can change a capsule's height, but there's limits to how short you can make it. You can make it taller if you want, but as long as it has a certain radius, it can be brought below a certain height. So it's very difficult to make a capsule collider that properly fits a donut too. So the long and short of it is you're pretty much screwed. You have to make a collider from scratch, and that would take my whole 2 hours here, so I'm going to have to figure out something hacky to do in the meantime, because I need to get this done. So let's think. What can I do that allows me to simulate striking the donut's edges without actually having any of the colliders that I need in place? So I'm going to create another object called colliders, and I'm just going to hack away at it from scratch because I have no choice. So capsule collider to start. Actually, let's start with a sphere on the inside, maybe. Yeah, I'll start with the sphere. I'm going to start with a sphere. That's going to be my interior collider, so that'll get the interior walls of the donut. Alright, next I'm going to make a box. And I'm going to make the box bigger so that I can see it. Okay, I'm going to move my box only over here. Check the edit collider box. Let's move my box over there. I'll place it at the top of the donut. Yeah, this gives me an idea. Alright, I'll center it, place it at the top of the donut, and then make it really wide. Just the width of the donut, in fact. So let's call it whatever the donut's width is. It's like 300, 400, sure, 400. 400, and I'll make it thicker. That's the ceiling of the donut. So when you hit the ceiling, you bounce off the ceiling, and since I have a ceiling, I'm going to copy it and make a floor. Floor will be at -60. Okay, so it has a floor. It has a ceiling, a floor, and a center. So now I just need walls, and I'm almost there. Now, I've kind of boxed it in like this. So ideally, I want to wall all of this. You would think, well, why don't I just build a sphere around it? But yeah, that's not going to work, unfortunately. I can't just put a sphere around it, because then it would always be hitting it. It's when you enter the collider that we're going to apply that magnetic force to it. It's not when you are within it. So if I just boxed it in with another sphere, like that, then I would have everything bounded properly. But, yeah, I don't know what I would do beyond that. Unless I want to do some kind of on-collider exit functionality. So this is something that I might consider too. Then I would actually have a perfectly bounded Toros, which would be pretty impressive, considering that I just thought of that and it's completely random. Alright. Let's do it. Let's do outer sphere collider. We'll call these the barrier colliders. And this one will be the outer sphere collider. And this one will be a sphere. And I'll see if I can hack this in, because I don't think so. I don't think I'll be able to pull this off, but I'm going to try. With these combined, we have a perfectly bounded Toros. As long as you are inside the outer sphere, but you're not touching any of the barrier colliders, you are within the Toros, I think, perfectly. So there you go. All you needed was 2 squares and 2 spheres to make a Toros. Topologists, write that down, okay? I just solved your whole field. Okay. Alright. Next order of business is the particles themselves. Now, the students had a lot of ideas on how this is supposed to work, and I can't validate most of those because I don't know enough about nuclear physics. But let's look up Tokamak fusion reactor formula. I want to see the chemical formula for the reaction. Wikipedia definitely has it. It's mostly history, but there's going to be a little bit in there too about how it works, I'm sure. Or not. Let's just look up DT fusion. Chemical formula. Okay, so we have H2 hydrogen with H1. This is the wrong kind of fusion. This isn't stars. We want the kind of fusion that people can do. That's the one. Yes, deuterium and tritium. So deuterium is the 2 hydrogens. The hydrogen's picked up a neutron, so it's not helium yet. It's just a hydrogen with an extra neutron on it. And then tritium has 2 neutrons on it. Neither of these are stable or something. And then when they meet, they create this fat helium, and a neutron flies off, and tons of energy is created. So we're going to create the game object that will represent any particle in our system. So we'll have a particle, and we're going to create a new script for this guy. And we'll call this just particle properties. I'll make a new folder for my scripts too. Scripts, and put particle properties in there. So every particle is going to have a particle properties script. What did I just do there? Particle properties script. I'm going to center this particle for now, and let's edit it. Okay, so first we're going to have a public int for the number of protons that you've got. Then we're going to have one for the number of neutrons that you've got. I think I spelled neutron correctly. Oh, I didn't. E before U. I'm going to spell that wrong every time. Oops. Okay, and there are some electrical formulas here that I'm going to gloss over for now. Do we need to worry about electrons? Well, if I remember physics correctly, the electron always hangs out with the proton, so probably not. Some fancy stuff happens when it turns into plasma, but we're just going to gloss over that for now. You just have protons and neutrons, which means that you can represent with this hydrogen, deuterium, tritium, helium, and also this free-flowing neutron here, which has a name, I think, neutrino, something like that, maybe? Probably not neutrino. Shows what I know about nuclear physics. Okay, let's have a void get particle common name. A string. I don't think this will be useful, but it might be useful for debugging. So, if protons is 1 and neutrons is 1, then this is regular hydrogen. Else, if protons is 1 and neutrons is 2, this is, I'm going to try to spell it correctly, deuterium. 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 Take a poll to see if you're awake. You tuned in for a mobile development class, and you ended up getting nuclear physics to boot. Tritium. No, 1 neutron is deuterium. 2 neutrons is tritium. You guys have no idea? Have you even done graduate level physics? I thought physics grad school was a prerequisite to taking the CS program. Okay, that's a free hydrogen. We also need to define the helium, the 2 neutron helium. Does that have a name? I don't think it has a fancy name. Definitely some positroning happening here. But that's not the kind, that's the star kind of fusion. We only want to deal with DT fusion, which is what the Tokamak does. DT fusion. Yeah, let's look at the reaction equation for a DT fusion. Check out Britannica. That's a classic source. Okay, so we get a 2 hydrogen. That's star burning. Okay, DT gives us a helium and a neutron. I can dig that. I get it. And then does the helium have a name? No, it's just helium-4. Okay. So you get regular helium according to this. According to Wikipedia, you got helium-4. So who's telling me the truth here? And then this is back to stars again. There's the Tokamak, in case you were curious as to what that looks like. You have a donut surrounded by magnets, there's a plasma there, and the magnetic field is what keeps the plasma suspended. And in fact, it looks like scientists already figured out what I learned about colliders, that you need an extra field at each pole. Apparently, unity colliders work the same way real-life physics does, so who would have thought? Now, they actually have circle colliders instead of boxes. We don't have circle colliders in Unity, except 2D ones, which we can't really use in 3D. So this is an interesting difference, but actually quite similar if you think about it. So we're actually getting a very similar property. Okay, this is a lot of words that I don't particularly. I just wanted to know if it was helium-4 or helium-3. This just says helium. Well, alright, that's as much as I'm willing to learn. So that's free hydrogen. And I'm going to add support here for helium-3 and helium-4 in case we decide to implement either one down the road. So that's going to be helium. I'll just call it regular helium. That's the scientific term. That'll be helium-4. Well, wait a second. Of course it's going to be helium-4 if it's DT, because you have 2 and 1, but then the one neutron breaks off, so yeah, you're going to get helium-4 and a free-flowing one. Else, return another particle. Okay. When the 270 people were designing this, they came up with lots of different inheritance structures, but really there's just one particle. What is up with this thing? What did I do there? Can't find string. What the heck? Oh. Stupid. Stupid Java knowledge making me capitalize things that aren't capitalized in C#. Alright. It's still giving me a convex mesh warning here. That's strange. I don't have a convex mesh anymore. Guess I just need to clear my console. Okay. That's my particle. Alright. Now, if you have protons, neutrons, or whatever, it should draw them for you. So let's create a sphere. This is going to be a proton. I'm going to handle the particle collision using a single collider. So I'm going to remove the collider from the proton itself, and then we're going to add those to the particle. So the particle will have one big sphere, so there will be a little bit of clipping, but that's fine, because I don't think that atomic particles really touch either, technically speaking, so close enough. And obviously this is not for scale. If you had a tokamak, this is like 1 trillion times bigger than a particle would actually be, but it didn't say to scale. Notice that in the description. So I can get out that way. So protons are probably going to be red, I think, by convention. So let's make a red background. Go with a prettier red. Maybe more like a salmon. And you don't want to use red and green if you can avoid it, because lots of folks out there are colorblind, so we're going to use blue for the neutron. That'll be neutron blue. Make a material for those two things. So that'll be the proton mat and the neutron mat. And proton mat gets proton red. Neutron mat gets neutron blue. Technically I have to check that Alpha's transparency box, but neither of these have any transparency, so it actually doesn't matter for them. I'm going to apply the proton mat to my proton. Ooh, shiny. And let's go ahead and make another light source while I'm at it so that there's more than one sun in place here. So that's going to be, this will be the main light, and I'm going to make this will be the reverse light. Good enough. And this one will just be weaker from the bottom. And that should work for my proton to be more illuminated. Alright, cool. That was light from both sides. Of course, protons don't actually get light. That doesn't make sense. So purposely left to scale out of the requirements. Well, maybe. To be honest, I didn't think anybody would pick it, so I didn't give it that much thought. I just thought that the description of making nuclear fusion and it being easy would be enough to turn anyone away. But 3 different groups bid on it, and they were like, yeah, I want to make nuclear fusion happen. I can do that. It seems easy. Dummies, come on. Now I have to write the knockoff version of it thanks to you. Let's copy the proton. And this will be the neutron. Yeah, you can also turn off the ability to cast and receive shadows on these things. I'm going to do that now because I think that that's going to benefit the performance a bit. And that's going to be important here. So we're going to turn off receive shadows. We're going to turn off cast shadows. We don't need either of those two things. I'm going to do the same for the donuts material too. Neither receives nor casts shadows. It's transparent anyway, so it doesn't matter. I can turn off light probes on it completely because it's just a simple transparent material. I can make both of these proton mats mobile, proton and neutral mats mobile friendly too. I can use the mobile simple diffuse. It looks ugly as crap, but it is much cheaper computationally. And if I'm going to have like 1 million of these in the scene, which I hope to put as many of these in the scene as my $150 Nord can handle. So we'll see how it goes. Looks like a physics textbook to me anyway. Boom, these two collided together. Woo! Fusion! Alright. Yes. It's either nuclear fusion or a multicolored butt, either or. Now, how do I make it so that a particle has a bunch of these? Alright, so back to my assets. Let me make a prefab folder. So obviously I have a prefab of the proton object and a prefab of the neutron object. I'm going to give both the prefabs a 0, 0, 0 starting position. That's just something I do out of habit. I don't think it actually affects anything. And now, based on my particle script, I want to create protons and neutrons for the particle at runtime. So I have to create a game object that will hold the prefab. So this will be the proton prefab. This will be the neutron Pre-gab, prefab. Okay. And not only does it have to create them at start, but then when you gain or lose a neutron or a proton, it has to create them too. And then there's the really complicated question, what happens when two particles collide, right? Who gets which? Who becomes the new particle? Who loses their particles? Right, so I'm going to have to figure out what happens when two of them meet. Now, one thing I'm going to do is that if you are empty, if protons is 0 and neutrons is 0, you're going to destroy yourself. So you'll just commit suicide if you are an empty particle. And I want to update the amount of neutrons and protons in this. If I do it in update, it's going to be really, really expensive. So I'm going to write a method for it. Void update particle animations. Or update particle animations. Update particle display is probably the better terminology to use. So this is going to updates the visual representation of the particle to the right number of protons and neutrons. Okay, so I want to create a certain number of protons and a certain number of neutrons, and I'm going to have a, let's say, array list of all of them, maybe. Did I spell it wrong? I probably did. Look it up real quick. Sure, this answer from 2013 seems good. From back when Unity used to support JavaScript. It doesn't anymore. This was remarkably difficult to find. Is it just that I didn't use the generic list? I know I have to import system.collections at some point. I mean, I could just use list, but... Oh, is it just parentheses in C#? This is a remarkably stupid problem to have. Where's the freaking array list with the... Okay. Array list of game objects. I could just use a generic. It really wants me to use a generic list. Well, I guess since all the answers use a generic list, and use a generic list, that seems to be what everybody does. When we're in C#, we'll do things the C# way. Okay. If list it is, then list it shall be. What is list in C#? It's just the default collection. Right, okay. Okay, so at the beginning for I equals 0, I is less than protons, I plus plus. instantiate a proton. Everything will always be rotated to identity, which doesn't matter because spheres look the same no matter what direction they are rotated in. This might be overkill now that I think about it, because an array probably would have been good enough here. And this is probably too much, because then I'm going to have to remove them, and that's going to be a real bear of a problem to remove them as you go. So let me think if I want to convert this to an array instead. If I convert it to an array, then I'm limiting the number of elementary particles that there can possibly be to however big the array is, and then I have to deal with the fact that it's going to have null spaces and all that stuff. But at least arrays, you can add and remove things, and there's no chance of thread faults or removals or whatnot. They don't care. So think. Is it a good idea or a bad idea? The most particles I can have is 4, so that's not too many. How often does the particle display get updated? Well, we'll try it this way, I guess. Okay. So this is going to be used to display, used to store the displayed prefab objects. Alright, I need to position them somehow so that they're not all kind of smushed together. So let me try to build a sample particle and see what it would look like. Let's say I had a 2 proton, 1 neutron thing. So I have a helium, let's say. So I would drag 2 protons in there and 1 neutron. And how would I space them in order to make it not ugly? So I guess I would take this one and move it, say, -1, or is that why you don't want them to be separated, you know, in the little physics textbooks? I guess the first one can be at 0, then the next one would be at like minus, let's say 0.75, so they're still touching. That looks cool. And then the next one would be like halfway between them, -0.5, and then maybe -0.5 on another axis. That looks like a physics textbook. Yeah. Okay, let me play with a couple more different possibilities. Let's say that there's just a proton and a neutron. Does that still look good? Yeah, that still looks good. Alright, how about a proton and, well, if it's just a neutron, I'll just be the front. Okay, I'd be fine. What are the other possibilities again? Oh yeah, 2 neutrons and a proton. So this one would be at 0.75. I said negative for some reason, but it doesn't matter. Okay. So that still looks good. And then I guess the last one, the only one that's complicated, would be the H4 one, then, the one that has 2 protons and 2 neutrons. So then the very last item, that last proton, would have to be at, let's say, 0.5 and maybe 0.5 on the other axis. Does that look good? Yeah. Okay. Those all look good. Okay, let's mess around with particle then. These will all be my little samples. I'll delete them. I can recreate those guys. Okay, this will be my little sample. So 7.5 for the first one, then 0.5s on different vectors for the others, with 0 as the base. Okay, so let's just create unique vectors for all of these. Private vector 3 first particle, or second particle placement equals new vector 3. That's 0.7500. Third particle placement is going to be 0.50, and fourth particle placement will be 0.5. All right, and now I want to instantiate based on the count of particles placed so far. So int particles equals 0. Oops. Num particle. Every time you make a new particle, we'll go num particle plus 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 plus, and we'll say vector 3 position. Okay, so I'll write a method for this. Void get particle position int particle number. This will be a vector 3 actually. This will be used only locally. So we're going to do a switch on particle number, case 1, default. Return vector 3 dot 0. Case 1 will return second particle placement. I guess that should be case... yeah, that's going to be confusing. Oh well. Case 2 will return the third particle placement. Case 3 will return the fourth particle placement. Notice I don't need breaks here because I'm returning anyway. So I don't need to break out of my case statements because I'm returning anywho. Okay. Returns the local position adjustment for a particle for the particle being placed at that index in the particles list. So it's going to be the transform position plus get particle position of particle. I don't need a variable for it, I can do it all in one line. Make it a little prettier. Okay, and then I'm going to condense all of that into a method as well. Void replace particles, I'll call it regenerate particles. And in order to make this method able to be called from anywhere, I'm also going to clear the array list before we start. So it'll be cleared, and then we should be able to regenerate everything. Okay, so if I run this, it should build my little particle guy here. I have to link the prefabs first. Link the proton. And then I kept the array list public for now so we can see what happens. Ooh, what a beautiful particle. I'm not going to show you what it looks like on the phone because it's too small to see. Alright, let's run it again with 2 and 2. Ooh. And with 1 and 1. Ooh. And with 1 and 0. Ooh. And with 0 and 1. Ooh. Okay, so now we have all the different particles that we need. Okay, bringing us back to updating the particle display. That's basically just regenerating the particles, actually, so I've already done that. I guess I don't need to do it. I can just move this comment over here. Did it elsewhere on accident. Okay, what's next? Probably collision or something. Okay, let's make a collider for the particle. Make it slightly bigger than the largest particle that you can have. So let's say helium there. Ah, but I didn't center them, did I? That could be a problem down the road, that I didn't actually center those things. So maybe it would be better if I centered the particles. So some will be negative. Let's just add a few random negatives to them. Forgot to save. That's silly looking, but centered. So I just need to think about this a little bit more. Let's say that I want them centered around, so I'm going to make a test. So, proton, proton, neutron, neutron. So if I want to center them, let's say minus 0.5 for the first, maybe positive 0.5 for the next. And then maybe negative 0.5 for the last. Or positive 0.5 for the last. That doesn't look as nice though, does it? So maybe negative 0.5 in a different direction. The z-axis. That doesn't look quite as nice either. Closer. But now it's not centered again. How do I make it look nice, but centered? Try this again. Let's undo my edits here. I guess this isn't bad. All I have to do is make sure that the collider is centered properly around the actual middle instead of the middle. So if I centered the collider around minus 0.5 or so, or I think it's positive 0.5 or so, then I think it would capture all of them pretty well. Yeah. Yeah. It's a good looking particle. Might want to scoot it over a little this way too, and a little this way, and also make it slightly smaller. So let's move it up by 0.25, 0.25 over in that direction. Probably over-adjusted. Better than the zeroed out version, but still not quite there. Maybe too far on the y-axis. Maybe fine. And then slightly smaller would roughly get it. Okay. And I'm going to try a few different variations. Let's try the 1 and 1 and see how well it captures that. Not bad. I think the radius of 1 was probably better. Again, they don't have to touch perfectly, but I want it to be relatively realistic when they make contact. 2. Okay, good enough for government work. We're going to stick with that collider. It's a little bit weird, but we'll stick with it. I did forget to parent these objects to the game objects transform. I should do that. Another problem is that when they get regenerated, it's going to create all new game objects. It's going to be annoying. All right. So there we go. It's a little bit cleaner. Now I can do stuff to it. So new particle dot transform dot parent equals this transform. So now when I run this, I should see them get parented. Cool. Now they're in the hierarchy. That's good. And they're all available in this particles array, which is also good. I'll probably use that to access them down the road. I'll probably loop through it, find a neutron, and give it to the thing it collided to or something like that. Okay. I think I've thought of everything here, so that looks good to me. Alright, so I want physics, which means I need a rigid body. And I'm going to put the rigid body on the invisible game object placeholder doodad for the protons and neutrons things. Now, I don't know if the magnets and whatnot are actually proportional to the like size of the particle, like how many protons and neutrons it has and everything, but I'm going to guess, so we'll see. Alright, let's see what happens when I run this relative to that outer shell collider. So that outer shell collider, it's not happy with it. It just teleports me beyond it because that shell is also taking physics, and as soon as you hit it, you just get warped to the edge of it. So if I make that a trigger, then it no longer is affected by physics, but it makes it a big pain in the arse to do rigid body things with it. So anyway, let's play around with what happens when a particle whacks the sides of the torus. Might have to move the barriers down slightly later on. Okay. So our little particle starts up there, and then gravity brings him down to the side of the torus. Boom. Okay. Let's have an update rigid body method. I'm definitely going to do a lot with the rigid body here, so I'm going to make a variable for it. And if there's no rigid body attached to this for some reason, we're going to destroy ourselves. Just a sanity check to make sure that none of the particles don't have a rigid body at the start. Don't even think I need that, but just to make sure. Okay. Void recompute mass. Mass of a proton. 1.67. Mass of a neutron. 1 AMU. Thanks. So 1 U. Alright, what's the mass of a proton in AMU? Also 1-ish. Well, then we'll just do our units of mass in AMU, and we'll round and say that they're both 1-ish. So RB dot mass equals, well, really just the number of protons plus the number of neutrons. Nothing fancier than that if it's just 1. So let's see if that works. I'm going to recompute the mass at the start. Okay, so we should see my particle should now have a mass of 3, and it does. Cool, it has a mass of 3. Do I want it to have drag? I don't know, maybe a little. Drag is pretty expensive too, though, so I might end up getting rid of that. I guess protons don't really have drag. I can get rid of drag. Okay. So it's going to be affected by gravity. That'll be one of the forces that impacts it. There'll also be the power of the magnetic field and everything. So for this, I'm going to do some layering. So this is going to be the Tokamak shell layer. I'll call this the barriers layer. Yeah, reactor barriers. And all of the reactors stuff is going to be on the reactor barriers layer. Okay. Right. So I don't want you to be able to exit the torus. So I guess I'll work on the bouncing part first, and then I'll work on exiting the torus after that. So when you strike one of the barriers, it should apply a significant amount of force to you in the direction opposite to the direction you are moving, and that's going to simulate the effect of magnetism at the edges. So whenever you strike an edge, it's supposed to knock you back towards the inside of the reactor really hard. That's what would happen if you got close to the magnetic field, right? So let's add a new script. I'll call this barrier magnetic force. And it will be a property of the barrier colliders. Alright, so I'm going to want a Unity on collider enter. I'll copy it from Unity's official docs. So on collision enter, collision. And we'll try debug.log. Just call this other. So with this in place, I should be able to log the collision with the chamber side that happens when it strikes the bottom. Boop, there it is. Okay, lovely. And now I want to be able to add force to it. So rigid body RB equals other dot get other dot game object dot get component rigid body. There's probably a faster way to do it than that, or at least a less tedious way. Let's see, they probably have something on the docs page, don't they? No, I guess they don't. Unity get rigid body of other object collision. I'm definitely going to have to keep this probably. The rotation of the Y object is going to be important down the road, so I'll keep that. No, guess this is the fastest way to do it. Okay. So if RB is not equal to null, I need to apply force on it on the normal relative to the collision point. So I need to reflect it back where it came from. Back where it came from. So the... It looks like we only have a minute left anyway. So apply force in the opposite direction of the object's vector at which it struck this collision. Yeah, so if it struck it like, if it's the thing we're colliding with is here, and we strike it going this way, then we need to apply the vector this way. So we always need to take the opposite on, I think, all three axes in 3D of the direction that the object was moving when it struck. Okay, I think that's all the time we have for today, right? So hopefully we can get the Tokamak populated with a crap load of particles next time. For now, you're free to go, but let me just do some funky stuff before we sign off for fun. Since you sat through all of this, I think you deserve a little bit of entertainment. So let's add 50,000 force at other transform position. The radius of 5. I'm just going to add explosion force. Make them fly away. I think 5,000 will be enough. We'll see. And let's just make a bunch of particles manually here. Good enough. Alright, let's see what happens. Just bounces around. Okay, let's say that we move them apart a bit before adding them. Alright, here we go. Whee! Look at him go! Bouncing around in particle space. Alright, and now they're just rolling around. It's a start. Alright, that's it for today. See you next time.